This is lesson 8.2. In this lesson, we are going to continue talking about graphing quadratic equations. So we're first going to take a look at this section at the top here. And we've got our three different graphs, just like we've had in the past. And we're going to put some color on these so that we can kind of see them a little bit separately from one another. So we've got green there, blue here in the middle, and then on the outside, we've got red. All right, so these are our three graphs. What this is telling you, when we have an equation in this format here, so ax squared plus c, if c is greater than 0, then our graph of f of x equals ax squared plus c is a vertical translation. Remember, a translation means a slide. So it's a translation of c units up from the original graph. So in this drawing, blue is our original graph. It's that f of x equals ax squared. And if we're moving c units up, right, then we have the green one. So that's when c is greater than 0. So that's c right here. If that's greater than 0, it's sliding the blue graph up. If we have c less than 0, then that means that this equation, f of x equals ax squared plus c, is a vertical translation where the absolute value of c units down of our original graph. Now remember, it's absolute value because we can't have a negative distance. But if you think about it, if this was my original equation and it's -2, then the absolute value of -2 is 2. So that means I'm going down 2 units. Another way to think about it is -2 means I'm moving down 2 units. So that's the same idea. The other thing that you want to take note of is that the vertex for this graph is 0c. Okay, so 0, c. In other words, kind of like that y-intercept, right? That's where it's kind of touching the y-axis on this one because of the format of what we're working with here. And our axis of symmetry for this one is x equals 0. That vertical line, right? It cuts them in half right there. Whoops, I forgot to underline the word vertex. There we go. And we are going to take a look now at example 1. So we've got this equation here. G of x equals x squared minus 2. And we're going to be comparing it to that original function, f of x equals x squared. So we have looked at that one in the past, right? So we'll use blue for that since it's kind of the original color we've been using. If it's f of x equals x squared, well, if I plug in 0 for x, 0 squared is 0. If I plug in 2 for x, 2 squared is 4. So 2, and then up here at 4. -2 squared is also 4. Let's say I did 4. 4, well, I can't do 4. It's not too high enough. Let's do 3. 3 squared is going to give us 9. And on this side, -3 squared is 9. So that kind of gives us our general shape here. That's our original. Okay. So looking at that original there, now we're going to get some points, some coordinates for our function g. So let's go ahead and jot a table here in our notebook. So for example 1, we've got an XY table here. Something I want to point out to you, what we just figured out at the top is this part here, that -2 that we are that we have in our equation. Remember that the vertex is 0 and then that same number. So if I have this -2, that means my vertex is going to be 0, -2. So the middle value that I'm going to have on this 0, -2, that's that vertex right there. Actually, let's use purple here to remind ourselves that that's the vertex. And we're going to choose a couple points above and a couple points below. So let's just do -2, -1. We've got 0, 1, and 2. So I plug it in to my equation. We've got negative 2 squared is 4. 4 minus 2 is 2. Negative 1 squared is 1. 1 minus 2 is negative 1. And remember that it is symmetrical. So 1 is also negative 1. 2 is also 2. So let's put those coordinates on here. Let's use green this time. So negative 2, positive 2 right there. And then I have negative 1 right down here. 0, negative 2, 1, negative 1, and 2, 2. So we kind of notice right here, got this going on. So that's ours. Now we have to compare them, right? So I notice when I'm looking at it that both graphs are facing up. So let's kind of jot these things down as we're talking about them. So we're going to just kind of do some shorthand just to remind ourselves. So both graphs up. So they're pointing up. I notice that they both have the same axis of symmetry, right? I can still fold them in half on top of one another. So axis of symmetry, same. And we know that that is x equals 0 for that axis of symmetry. All right, so here's some things that I noticed are a little bit different. If I'm looking at this blue graph, right, that vertex is still 0, 0. But for the function g, that vertex is down here at 0, 2. So we're going to say f's vertex is 0, 0. G vertex is 0, negative 2. The reason that that vertex is 0, negative 2 is because I took my blue function and I translated or I slid it 2 units down from that graph of the function f. All right, let's take a look at example 2. So for example 2, we have g of x equals 4x squared plus 1. We're going to compare it again to that function f of x equals x squared. So that same blue graph that we had over here. So let's just jot that down really quick. So we had, we want to count these numbers a little bit differently. So let's do 2s for this one. So every line is going to be 2. Let's just kind of label every other one. So that's 4, 6, 8, 10, 12, 14, 16, 18, 20. And then going across here on the bottom, we can still just count by ones. So that's 2, that's 4, negative 2, negative 4. Just so we remember the bottoms, we were going by ones on the x-axis, and on the y-axis, we were going by 2s. All right, so I look at it, I notice that plus 1, so I know that my vertex is at positive 1. So let's go ahead and make our table. So we've got example 2. We know that our vertex was at 0, 1. We're going to go a couple above and a couple below. So we'll go negative 1, negative 2, and then we'll go 1 and 2. So looking at my function, 4x squared plus 1. So first I have to do the x squared. So negative 2 squared is 4. 4 times 4 is 16. 16 plus 1 is 17. Negative 1 squared is positive 1. Positive 1 times 4 is 4. 4 plus 1 is 5. We know that that vertex is the spot where they overlap over onto one another. That's our symmetry section. So we know that the 1 and the 2 are going to have the same value. So 1 is going to be 5 and 2 will be 17. All right, so let's go ahead and jot these down. Just realized that we numbered them and then we never put the blue graph on. So let's do that real quick. Here's our 0, 0. Then we had 2, 4, negative 2, 4. And then we have 4 squared is 16. And then we'll do negative 4 squared is 16. All right, so there's our blue graph. Let's take a look at our other function here. So negative 217. So we've got negative 2 and 17. So there's 16, 18. So we'll go halfway across. And we've got positive 217 as well. So I'm going to do that one right now. Negative 1, 5, 2, 4, 5. Positive 1, 5. And then 0, 1. So halfway right there. Okay, so looking at this, first of all, we notice again, they're both opening up. So both graphs up. Make sure we can see that. There we go. Again, they have that same axis of symmetry. So, oops, axis with an X of symmetry. It's the same. And this one, again, that axis of symmetry is that X equals 0. We notice that G, the yellow graph here, is narrower than the graph of F. So G is narrower. And its vertex is 0, 1. While F still has that vertex of 0, 0. So we squished or made it tighter together, right, for the yellow, and we shifted it up to 0, 1 instead of at 0, 0. So if we think about this in terms of what we've talked about before, that means that G is a vertical stretch by a scale factor 4 and a vertical translation 1 unit up from graph F. So G, vertical stretch, scale factor 4, and vertical translation 1 unit up from F. All right, let's take a look at example 3. So example 3 says, let f of x equals negative 0.5 x squared plus 2, and g of x equal f of x minus 7. So what we have to do in part A is describe the transformation from the graph of f to the graph of g. Then we're going to graph f and graph g on the same coordinate plane. So if I'm just to look at this really quick, I'm going to notice that I'm having all of function f here, right? All of this function, and then I'm taking 7 away from it. So just right there from that piece, I haven't graphed it or anything, I notice that because I'm taking the answers from function f and subtracting 7, that I'm going to take whatever the graph is of function f, and I'm going to be sliding it down 7 spaces. So for part A, example 3, we have vertical translation, right? Because we're sliding it down. Seven units down. Of graph F. Without even graphing it, I can see that from the equations, from those functions that they gave us, because they showed us right here that all the answers from function F, whatever I got, I'm subtracting 7 to get my points for graph G. So now they want us to graph it. All right, so let's do our table here. I'm going to do this table horizontally, which is a little bit different than we normally do, because then I'm going to be able to see a comparison easier. So I've got my x column or my x row first, then I'm going to do f of x, and then I'm going to do g of x. All right, and I am going to use the numbers -4, -2, 0, 2, and 4. So I'm going to start with the function of x, or f of x, sorry. So I've got f of x here, right? So if I plug in -4, -4 squared is 16. 16 times -0.5 is -8. -8 plus 2 is -6. Let's actually give that a color so we'll be able to see some differences in these. So that's f of x is going to be -6. All right, so then -2 squared is 4. 4 times -0.5 is -2. -2 plus 2 is 0. Plug it in 0. 0 squared is 0. 0 times -0.5 is 0. 0 plus 2 is 2. +2 squared, 4. 4 times -0.5 is -2. -2 plus 2 is 0. So notice this was our vertex, our axis of symmetry starts, that's the fold over point. So that means that this -4 is also going to be -6. All right, so for g of x, I want to just jot down for you and remind you of why we're going to get the points that we're going to get. So for g of x, let's just use this color. So g of x equals f of x, okay? So whatever we got for our function of x minus 7, okay? So if I look at this, so for g of x, if I were doing, let's say, g of -2, okay? So I got 0 for -2. So if it was g of -2, then I would take that coordinate. So I got 0 for the answer, minus 7. Well, 0 minus 7 is going to give me -7 for g of x, g of -2. So down here, we're going to get -7. Notice it's whatever that answer was, minus 7. So -6 minus 7 is going to put us at -13. 2 minus 7 is going to put us at -5. 0 minus 7 is -7. -6 minus 7 is -13. So now we've got our coordinates for both of our graphs, and we're going to put that on our graph together. So f of x, we had -4, -6. So we're going to do by 2's again. Okay, so we're going to label the x-axis. We're going to do every other one. So 2, 3, 4, 5, 6. 1, -2, -3, -4, -5, -6. And then we're going to count the y-axis by 2's. So -2, -4, -6, -8, -10, -12, -14, -16, -18, -20. All right, so for f of x, we've got -4, -6. So -4, -6. And then we have -2, 0. -2, 0. Here we go. And then 0, 2. 0, 2. 2, 0. And 4, -6. 2, 4, 6. So we're like this. All right, now let's do our g of x. G of x, we have -4, -13, 2, 4, 6, 8, 10, 12, 13. -2, -7, 2, 4, 6, 7. 0, -5, 0, 2, 4, 5. So we've got our two graphs here. And we are noticing that you can see the shift. You can see how they're not exactly the same positioning. So we know that we have that translation confirms what we said in part A. For part B, we have to write an equation that represents g in terms of x. So kind of what we were doing over here, right? We were plugging in f of x's value to figure out what g of x was going to be. So we have g of x. Let's use that color for that. So we had g of x equals f of x minus 7. Well, f of x is that whole equation. So let's get this written in here. So g of x equals f of x was -0.5x squared plus 2. So that's all of our f of x function. And then we're subtracting 7. So if we simplify this, when they're saying, hey, what is g of x in terms of x? So we would have g of x equals, notice this 0.5x squared doesn't have a partner, no like term, so that stays, -0.5x squared. -2 and or +2 and -7 combine to make -5. So g of x in terms of x is -0.5x squared minus 5. All right, and lastly, we're going to talk about a zero of a function for f is an x value for which f of x equals 0. So a zero of a function is an x-intercept of the graph of the function. So we have the function f of t equals 16t squared. It represents the distance in feet a dropped object falls in t seconds. The function g of t equals s sub 0, so it's like that 0 term, represents the initial height in feet of the object. So think about when we did the Barbie bungee jump. We found out that her height, that starting value, that's where she was. So that's kind of like what our s of 0 is. It's that initial height. So we're going to find and interpret h of t equals -f of t plus g of t for part A. So let's slide this up so we can see better. All right, example 4. We have h of t equals the opposite, or negative, f of t plus g of t. Let's use this blue one. So if I look back at this top, right, we've got our f of x right? We used green for that, or f of t, sorry. That's this part here. So that's 16t squared. That's going to go here. 16t squared. And then we notice that g of t is that s sub 0. So we're going to have plus that s sub 0. It looks like it says so. That is equal to our h of t. All right, so what we're going to do is simplify this, okay? So we have h of t equals the opposite, or negative 16t squared, plus s sub 0. So that's that first part that they wanted for us. Because this whole thing right here is in parentheses, because it's the whole function, right? So it's like I square these things, the t's, and then I make the whole answer opposite. Okay, so h of t is negative 16t squared plus s sub 0. Part B says, you drop an egg from a height of 64 feet. After how many seconds does the egg hit the ground? So we're using this function that we have here. Oh, this was part A. So we're still using that same function. H of t equals negative 16t squared. Now it says that our initial height is s sub 0, right? And they tell us in part B that our height that we're starting from is that 64 feet. So we're going to have plus 64. So they want to know, when does this egg hit the ground, right? So if I'm thinking about it, when does the egg hit the ground? I'm trying to get it so that the function equals 0, right? Because if it hits the ground, it's at a height of 0. So we could make a table. We could plot it and all that. We could do all those things. We also could take our function and plug in 0. 64. So we would subtract 64 from both sides. So we'd get negative 64 equals negative 16t squared. Divide both sides by negative 16. T squared equals 4. Take the square root, and we find that it would take 2 seconds after the drop. So 2 seconds after drop for it to hit the ground. Let's put that in a box so we know where the answer is. And then part C says, suppose the initial height changes by k feet. How will this affect part B? So if I'm looking at this and I'm looking at my seconds, right? And I'm thinking about my graph. And if I have the graph, like let's just jot a couple points on here. So if we're at 2, let's do our numbers here. So 1, 2, 3, 4. And then let's see how many lines we got. 1, 2, 3, 4, 5, 11. 11 of those. So let's count by 6s. So we're going to have 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66. So we knew that our height at 0 seconds was 64. So we're going to have to approximate that number on the graph. So it's just a little bit more than halfway up that spot. Then after 1 second, we would have 48. So 1 and 48. And then after 2 seconds, we're at the ground. So that's kind of what this graph looks like here. And I didn't draw an arrow on the end there because once I hit the ground, I can't go any farther. I can't have a negative distance, right? But if I think about it, so we're talking about K, right? So our height changes by K feet. Oh my goodness, it's a little too high. Sorry about that. So we're at K feet. Could be K feet more. It could be K feet less. So if I think about it, if I'm changing K and I'm increasing it, what's going to happen to my graph? Well, if it's higher up here, it's going to take longer to get to the ground, right? If it's lower right here, then it's going to take less time to get to the ground. So if we're thinking about it, if K is greater than 0, then it's going to take us more than 2 seconds. If K is less than 0, it's going to take us less than 2 seconds. So K is greater than 0, more than 2 seconds. If K is less than 0, then it's going to be less than 2 seconds. And that's for part C. Sometimes it just helps to have the visual of the graph to help us with that.